Hello, Uggies Worldwide. I'm Dave Kassler, here with another episode of Ask Dave. Today we're going to take a look at something that you may have heard about, but never used, and that's called radians. When we think about it, we divide a circle into 360 degrees. We're all used to that. 45 degrees, 90 degrees, and so on. Just rolls right off the tongue. Well, if you look at the scientific calculator, there's a little button on it called DRG. And that switches between degrees, which I just talked about, and radians, which we're about to learn about, and gradians. Gradians are kind of weird. They're certainly not used in ham radio. They're used by some surveyors and so on. And instead of 90 degrees in a quarter circle, there are 100. It's often been called the metric degree, but the degrees that we're used to for doing sine waves and things like that, sometimes it's easier to do things in radians. Now, a radian is where the total distance around the unit circle is 2 pi, or about 6.28, 2 pi radians. And a radian is actually the length of the arc from the 0 point to the point that we're interested in. Let's watch this little video that's taken from some no longer needed training material in the Amateur Extra book and see just what radians are. There's a little sleeper of a paragraph in the book that talks about something called radians. A radian is the length of the arc between 0 degrees and the angle we're interested in. How many radians are there in 360 degrees, or one complete revolution? Well, we know that the circumference of a circle is pi times the diameter. In this case, it is the radius that is 1 unit long, so the diameter is actually 2. So the total length around the circle, if you were to measure it with a tape measure, would be 2 times pi, usually written as 2 pi, or about 6.28. Here's the conceptual leap. We can actually represent the angle in terms of this arc length. When we do so, we are using radians. But note that if we do what the book says and use the formula of the amplitude at a specific time t is equal to the sine of 2 times pi times frequency in hertz times the time t, we're now dealing in radians. So you must set your calculator for radians. Oh, that little Greek letter that looks like a small w, that's actually the lowercase of the Greek letter omega. Yes, it is true. We use uppercase omega to indicate ohms. But we're using lowercase omega for something entirely different. And it is true that all engineering work is done using that little lowercase omega rather than 2 pi times the frequency. But we don't have to worry about it here. Just remember that when you see 2 pi times f, you're thinking in radians, not degrees. Well, there you have it. Radians. Now we know about radians. So whenever you see that funny little omega, you can just substitute 2 pi f, where f is the frequency in hertz. And wherever you see 2 pi f, you can always substitute omega. Omega is the angular frequency. It's how fast we're going around that circle creating sine waves in radians per second. If you want to convert that to cycles per second, then you divide that by 2 pi and you get the frequency, which is the number of complete cycles in 1 second. Hope that helps. Just a quick look at an interesting little feature of our calculators and something that you'll see from time to time in ham radio technical material. So please take a look at dkassler.com/support for different ways that you can help fund this channel. And until we next meet, 73.